Hello, we're working on our 3.4 notes. I'd like for you to update that in our table of contents. I'm going to be going fast through this video because I'm kind of tight on time. So pause it if we're going a little bit too fast. Okay, so standard form. The equation of standard form looks like this. It's capital A lowercase x plus capital B lowercase y equal to c. So its equations of the form looks like this, where A, B, and C, these are just numbers. We'll say are numbers. Okay, they could be decimals, they could be whole numbers. So an example here would be like 3x plus 4y equal to 7. Okay. Steps to write an equation in standard form from a written description, which we're going to do for this first one, is you're going to let a variable represent an unknown value. We're going to actually have two unknown values. And number two, write a value as the coefficient. Right, coefficient is, we talked about this in equations, a number in front of a variable. So an example is like 5x, the 5. Okay, number one, the admission fee at a soccer game is $1.50 for children and $4 for adults. On a certain day, $300 is collected. So what do we not know here? We don't know number of children and adults that attended the game. So although we're not going to have X and Y here, we're going to have C. Let's have C be number of children. We don't know what that is. All right. And then for number of adults, let's have lowercase a here. Number of adults. Okay. So if in standard form it's this, right? Equation that could model this is, let's say I put C right here instead of X, lowercase c. Now, the value for each child is $1.50, so I'm going to put 1.5 instead of 1.50. It's still the same thing. And let's say I put A here, lowercase a for lowercase y, and it was $4 for adults. So this would be plus 4a equal to 300. Okay, this is an equation that could model this situation, where we could use this for something else in our chapter to identify number for each kid. Okay. Anyways, number two, Gibson Middle School rented buses and vans. So it looks like those will be our variables for a field trip. There were 8 vans and 12 buses for 360 students. So what do we not know, right? If we're caravanning a bunch of kids, right, we don't know. Let's say B for buses. What is the bus's capacity? Right, how many students can fit in the bus? And let's have V, that'll be the van's capacity. And I'll put cap here. Okay, so we can go in that order. Order doesn't matter, right? You could put B in front of V as long as you have the right coefficient. For buses capacity, we know that there are 12 buses, so this will be 12B. And for V, for the van's capacity, we know that there are 8 vans, so 8V equal to 360. Right, so this is slightly different than what we'll get to later, which is slope-intercept form. For standard form, you have 2 different rates here because we have 2 different variables, but this is pretty much the extent that we'll go through, at least for this, of just writing an equation. Okay, all right, we're going to get to special graphs. And that is horizontal lines and vertical lines. These have a specific type of slope. We'll get into slope later on 3.5, but for 3.4, let's look at it. So for horizontal lines, it's of the form y equal to b, where that b value is where it crosses the y-axis. So the graph of y equal to b is a horizontal line. The line passes through the point 0, b. So our graph here is y equal to 3. So first of all, I like for us to put a point at 3 on the y-axis. That's step 1 really there to graph it. And step 2 is you just draw a horizontal line through that point. That's all you have to do. And close enough here. Okay. Now the question here is why is this the case? Okay, so what I'm going to do is I'm going to pick some other points on here. This isn't super necessary when you graph, but I'll do this to just demonstrate it. You don't have to write what I'm going to write in red unless you want to. Let's say this point here. This is the ordered pair. That is -4, comma 3. And let's say I pick this point here. That is, I think that's 6, comma 3. Okay, what do they both share? They both share that the y value is 3, and that's why it's y equal to 3. Okay, you could pick any point. All the y values will be 3. This is a function. The one out to the right for vertical lines. As we can see, it's a vertical line. This would not pass the vertical line test, but we can still write an equation for it. So this is of the form x equal to a, and this is where a is on the x-axis. Okay, so the graph of x equal to a is a vertical line. The line passes through the point a comma 0. So we have our point here. X is equal to -4. So let's find -4 on the x-axis now, right? X-axis is right here. -4, 1, 2, 3. Looks like it's right here. Step 1, put the point. Step 2, we'll draw a line through that point. Put arrowheads. Okay, and that's all you have to do. Again, one more time, I'll put this in red. Not necessary that you copy this, but to prove why this is the line x equal to -4, let's say this point here. That is the coordinate, -4, comma 5. Let's pick this point. This is the coordinate, -4, comma -2. What do we notice they have in common? The x values are all -4. That's why it's x equal to -4. Okay. Let's switch over to the backside. Again, if I'm going too fast, make sure you pause this. We're going to cross something off on the backside, but let's go ahead and start this next part. Okay. It is possible for you to graph lines using what's called as the intercept. So what are these? What is an intercept? This is something you maybe would have heard in your 8th grade level math class, but let's talk about this. The x-intercept is a point on the line that crosses the x-axis. Okay. Just similarly, right, the y-intercept is a point on the line that crosses the y-axis. I'm going to give you a line before we fill out these next parts here. Can we do this? Let's put a point right here. And let's put a point right here. And let's draw a straight line through these points. Something like that. Okay. Now, these coordinates, let's write the coordinates here. This is the y-intercept because it crosses the y-axis. That is the point that is 0, comma 2. Okay. And over here, this is the x-intercept. This is -4, comma 0. Okay. When you're finding the x-intercept, the y value is always 0. As you can see here, right, y value is 0. If you look right there, y value is 0. The y-intercept, I'll switch the color here. Right, when you're finding the y-intercept of something, the x value is 0. It's always the other variable. Right, let's highlight this. Notice here, our x-intercept is right, x-intercept is 0 at the point -4, comma 0. Okay. All right. So let's go and write this here just so you can get a quick visual. I'm just going to put an arrow. So the y-intercept, it's right over here. And the x-intercept, that's right over here. Okay. The part I like for us to cross off, we're going to cross off this part. We're not going to use this. We're going to get to our 2 examples here of how to graph using x and y intercepts. So example 1, identify the x and y intercepts, and then we're going to graph a line. You just need 2 points to graph a line here. We have the equation 6x minus 4y equal to 24. So what we're going to do here is I've rewritten both of these. For the one off to the left, x-intercept, we're going to set, like I said, I'll put this in red, the other variable, y, equal to 0. We're going to rewrite this, but where instead of the minus 4y, it's going to be minus 4 times 0. So let's rewrite 6x minus 4. I'm going to plug in for y, but for y, we're going to put a 0. Okay. Now, order of operations, we can simplify some things here, but this all becomes 0. That's why I'm circling it. and we're going to have 6x equal to 24. If you divide both sides by 6, you're going to find the x-intercept, x equal to 4. That is the coordinate 4, 0. So let's graph that. So on the x-axis, where's 4 at? It's right here. And like I said, that is the coordinate 4, 0. Okay. Now, in order to graph a second point, I need to find the y-intercept. Where does this cross the y-axis? For the y-intercept, you're going to set the other variable, x, equal to 0. So let's rewrite this equation where we have an x for 0. So 6, instead of x, I'll put parentheses. I'll plug in a 0 later. I'll put this in red. All right. 6 times 0 is 0, so that goes away. And let's rewrite everything else. Negative 4y equal to 24. We'll have to divide both sides by negative 4. Y equal to negative, looks like that's negative 6. Now using x equal to 0 and y equal to negative 6, that gives us the point of 0, negative 6. All right, so where on the y-axis, where is negative 6 at? It is right here. And like I said, that is the point 0, negative 6. Let's go ahead and draw a line connecting both of these points here. So that means that this red line is the line that models the original equation, x equal to negative 4y, or 6x minus 4y equal to 24. Okay. All right. I'd like for you to try this last problem as a you do, but the parts I will fill out for x-intercept, we're going to use this equation, negative 2x plus 2y equal to 10. Right? Y is going to equal 0 here, and x is going to equal to 0 for here, which is the y-intercept. When you're done with this, you'll go to Big Ideas and try the 3.4 assignment.